Hello, class. This is Mr. Hart, and in this podcast, we want to continue our discussion of similarity and geometric proofs. Last time, we looked at dilations, and those are going to be very important for discussing similarity and how similarity works. Okay. So before we start with similarity, let's just get some vocabulary words down. Okay. And so there's two basic ideas with geometry and looking at shapes. And one of the things we can look at is if shapes are congruent and if shapes are similar. Okay. So if shapes are congruent, that means the two shapes have the same sides, they have the same angles, everything is equal. Okay. Their side lengths and angles are equal. Basically, they're the exact same shape, just in two different spots. Okay. And so geometry, we give it this fancy word, congruent. It really just means equal. Everything about the shape is equal, the sides, the angles. Okay, it has all the same properties. This can be applied to triangles, rectangles, whatever it is. Okay. Congruent shapes are basically the exact same. Okay. Now, similar shapes are basically, they're very similar. Okay. They're one shape. It's when one shape could be dilated to be congruent to the other shape. Okay. So you basically have the same shape just in two different spots, but one may be bigger or smaller than the other. Okay. So when we're looking at similarity, we're trying to determine, are these shapes able to be dilated into the other shape? Okay. Let me just give you a visual so you can kind of see. Okay. So we're going to look a lot at triangle similarities. Okay. And with triangle similarity, we're saying basically, can this triangle right here be dilated to be that triangle right there? If I made this triangle right here bigger, would it be the exact same as this triangle right here? Would the angles be the same? Would the side lengths be the same? Okay. Can I dilate one to get the other? Okay, that's the idea of similarity. So that's why we looked at dilations, because we want to be able to see if we times this by some scale factor, can we get that shape? Okay, and if we look right here, this triangle, if we look at all the sides, this side compared to this side compared to that side, and this side compared to that side, you'll notice that each side could be times by 2 to get these side lengths. Okay, and so the scale factor of dilation would be 2 to get from this one to that one. Okay, so if I times this by 2, I dilated by 2, I'd get this triangle. So these two triangles are similar. Okay, one can be dilated to be the other. Okay, and so also one thing to keep in mind is that the angles are the same. These lines right here mean the angles are the same. This angle is equal to that angle. The two lines mean this angle is equal to this angle with two lines, and the three lines means this angle is equal to this angle with three lines. Okay, so all the angles are the same. The sides could be scaled to be the same, and so they can be dilated, which means they're similar triangles. Okay, and so we could do this process every single time of looking at every individual angle, looking at every individual side, making sure the scale factors are the same, making sure all the angles are the same. But that sounds like a lot of work. Okay, let's look at an easier way to determine if triangles are similar. Okay, so we basically got three tools in our toolbox that we can use in order to determine triangle similarity. Okay, so we call these the triangle similarity conditions, but they're basically shortcuts. Okay, they're cheat codes, you could say, shortcuts to figure out if two triangles are similar. Okay, so the first one's called angle-angle similarity condition, the second one's called side-side-side similarity condition, and the third one's called side-angle-side similarity condition. Okay, let's look at each one. So angle-angle similarity condition means if I have two triangles, okay, and I don't know if they're similar or not, but I know they got two angles that are equal. Okay. Turns out, there's a way to prove this. We're not going to worry about that right now, but it turns out if you have two angles that are equal on a triangle, they are similar. Okay? You don't have to use any type of side lengths to find anything. You don't have to determine the third angle, although it will be the same. Okay? We don't even need that. Okay? Two angles on that triangle, no matter which two angles they are, and we know that they are the same, then the triangles are similar. Okay, that's a huge shortcut. Okay, we don't have to look at any side lengths. Okay, so if we're trying to determine if two triangles are similar, we can use angle-angle condition, or we'll abbreviate it as AA. Okay, So you see these two triangles, you can say by AA we know they are similar. Okay, so that is one shortcut. Another really nice shortcut is the side-side-side similarity condition. Okay, and how that works is, let's say I have a small triangle here and a big triangle here. This one has side lengths 3, 2, and 1. This one's got side lengths 6, 4, and 2. Okay, but I don't know anything about the angles. Okay, but here's the cool fact. If all these sides scale by the same amount to equal this triangle, and in this case they all scale by a factor of 2, right? This scales by 2, that scales by 2, that scales by 2. Okay, if all the sides can scale properly, then all the angles will be equal, and so the triangles are congruent. Okay, so I don't have to look at the angles at all if I know the sides scale properly. So that is the side-side-side, or SSS, similarity condition. Okay, and the last one is the side-angle-side similarity condition. So I got two triangles, and I have, let's say this one is 6 and 4. This one is 3 and 2, and they have an angle that they share. Okay, sorry there, I had some technical difficulties. Okay, but going back to this, so let's say we got two triangles. Okay, I know a little bit about the side lengths. I know a little bit about the angles, or I know at least one angle. Okay, what we want to be able to do is, we can't use side or use angle because we don't have enough information for either one. But if these scale by the same factor, so 6 goes to 2 and 3 goes to 1, that's a scale factor of 1/3, and then they have an angle that they share between them, then you also know that these triangles are similar. Okay, and so we call this side angle side, or SAS. Okay, so keep in mind, the sides, both sides have to scale by the same factor, and the angle has to be between the sides. The angle has to be between the sides. It can't be this angle up here, right? Because that angle is not between the sides. It's on the opposite of those two sides, right? Or it's outside them. It has to be between those two sides in order for this to work, okay? But if I got that angle between the two sides, the sides scale by the same factor, then you can use side angle side, okay? So there we go. We have 3 tools that we can put in our toolbox: angle, side, and side angle side, in order to determine triangle similarity. Okay, this saves us a whole lot of time because we don't have to look at every individual angle and every individual side. Okay, let's look at some example problems of how we can use these guys to help us out a ton. Okay, so let's look at these two triangles. Okay, so determine if the following triangles are similar. If so, write a similarity statement. Okay, well, we don't know a whole lot about this triangle. All we know is we got an equal angle there, and we got an equal angle there and there. Okay, I mean, the two triangles look like they could be similar. I could dilate that one, but we don't know a whole lot of information. Fortunately, we have the angle condition, okay, which says if I got 2 equal angles on both triangles, then we know the triangles are similar. Well, that one is equal to that one, and that one is equal to that one. So there we go. We got angle condition. So yes, these are similar by angle. Okay, done. That's it. Super easy. Saves us a whole lot of time, and we just need to know 2 angles. Okay, let's look at another problem. Okay, so let's determine if these triangles are similar and determine the similarity statement. Okay, so now we got a couple of angles here. We don't know anything about the sides, so we probably want to still use angle, but notice we got this angle on this triangle, and we have this angle and that angle on this triangle. So before we can write angle, we have to get make sure the angles are the same. Okay, because initially it might seem, well, that's 35, that's 55, they're not equal. But let's find this angle right there. So if we find this angle, what we have to do is we know that all the angles inside a triangle add up to 180. And so we're going to do 180 minus 35 minus 90. And that will give us that this angle is 55 degrees. Similarly, if you did 180 minus 55 minus 90 for this triangle, you'd find that this is 35 degrees. Okay, so now we can see, okay, these clearly have the same angles. We only needed 2 though, but 3 is plenty as well. So this angle and this angle is the same as this angle and that angle. Okay, so now we have angle, angle. So yes, they are similar by angle, angle. Okay, and there we go. They share 2 angles that are equal. So yes, they are similar triangles. They could be dilated to be the same triangle. Okay? All right, let's look at a couple more examples to make sure we got this down. Okay, so now we want to determine if the following triangle is similar, figure out the similarity statement. Okay, in this case, we know all the side lengths of both these triangles. We know each side length on these triangles. We don't know anything about the angle. So this is probably a good hint that we want to use side, side, side. So let's look at the scale factors on this guy. Okay. So before we do that, though, we have to match up the side lengths to each other because as they are right now, they're not facing the same direction. This triangle has the flat side along here, and this one has the flat side along here. So we kind of have to flip this around. So the easiest way to do that is to start with the smallest side and go up. So this is going to be the smallest, and that one's going to be the smallest. Okay. That's a scale factor of 9 compared to 6. And that's going to be about, what, 1.5 or 3/2. Okay, now let's look at the next 2 biggest ones. So this is the next biggest. This is the next biggest. And that's going to be 12/8, which also gives us 1.5. This is a good sign. And then this one is the next biggest, and this one's the next biggest. So that's going to give us a scale factor of 18/12, which is also 1.5. So there we go. All 3 of those sides scale by the same factor, 3/2 or 1.5. So yes, these are similar triangles by side, side, side. Okay? Each side is scaling by the same amount. Okay? If one of these had not scaled by the same amount, then no, they wouldn't be similar triangles. Okay? But if all 3 are scaling by the same amount, we don't have to look at the angles at all. We can say, yes, these are similar triangles by side, side, side. Okay? All right, and let's do one more problem to make sure we got this down. Okay? So last of all, determine the following triangles are similar. If so, write the similarity statement. So now we got some information about the angles and the sides. So we're probably going to want to do side, angle, side. Okay? So first of all, let's just check, are these angles congruent? Or are they equal? And yes, that angle is the same as that angle. Okay? Now let's do scale factors. So again, they're not aligned the same, so start with the smallest side. So 4 going to 6, that's going to be a scale factor of 6/4, which again gives us 1.5. And then the next side is 7 compared to 10.5. So 10.5/7. Let me just make sure that gives us the same thing. 10.5 divided by 7 also gives us 1.5. Okay, so there we go. We got 2 sides that are scaling by the same amount. We have 2 congruent angles, and the last thing to check is to make sure that this angle is in between the sides. And yes, it is in between those 2 sides. This one is in between those two sides. So yes, these are similar by side, angle, side. Side, angle, side. The 2 sides are scaling by the same amount, and you have a congruent angle or an equal angle. Okay? So there you go. So that's your homework. You're going to be given a bunch of different triangles. You have to prove if they are similar, either using angle, angle, side, 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 or side, angle, side. Okay? It's always going to be one of those 3. You probably won't ever have to find every single individual angle and side to prove it. Okay? Use those shortcuts. Use those cheat codes, as I call them. Okay? Find which way to prove it easily. Okay? But that's it. Make sure you have angle, angle, side, 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 and side, angle, side down. Hopefully that all made sense. Let me know if you have any questions, and thank you for watching.